All right, have at it.
All right, go ahead, Mike.
Awesome. So, hey Keith, thanks for joining us here. Yeah, so I'm going to go through the demo, but then I don't have any sort of formal presentation or anything. So feel free to jump in, and like host Seb said, we're very interested in your feedback. So feel free to jump in with feedback as well. Unfortunately, I it says host disabled screen
Oh,
sharing.
let me allow screen sharing. Hold
Yeah.
on.
So Keith, just to before Mike starts, what we're trying with NetApp is doing is, we had the cloning snapshots for a very long time, and we started thinking how can be that helpful for data science teams, data engineering teams. Obviously, the data science people that we hired, we asked them, what was the problems that you were going through. They all mentioned that model versioning along with the data is one of the biggest problems that they have today. Think about it. If a data scientist today trains the model on a certain amount of data or certain types of data, and after a year, they want to retrain that model to go back to the results they had a year ago, they are at the mercy of someone not tampering the data. They are at the mercy of that data scientist staying around so they know which data has been used. And usually we learned that most of them do it on a spreadsheet saying the training at this day was run on the data existing in this shared folder. You can easily model the version. That's not a problem. GitHub has that functionality. Most of the ML ops have that functionality. But taking the data as part of the model version is one of the problems. Oh, Mike, go ahead. Yeah, I
Yeah,
think you have it over here.
yeah. So it's really these three slides that I showed on Thursday that kind of highlight the problems we were trying to solve, right? I mean, the first is creating, the first is the scenario where a data scientists or multiple data scientists are working off a gold source data set and running different experiments on that data, and so they don't want to modify the gold source, but for each experiment they have to manipulate the data set in some way, reformat it maybe into the right kind of feature vector to fit the model architecture right, run different normalization techniques. And so um, yeah, what a lot of customers we talked to were doing were basically copy paste, right? And waiting hours while they copied these data sets all over the place, and there was kind of no tracking built in. It was a very messy manual process, and they were sitting around for 17 hours drinking a coffee, right, when we can help them clone a data set into in 2 seconds.
So let me
And then
understand the workflow. So basically,
yeah,
if let's say that I have a bunch of baseball data, and
right.
this data is streaming. Let's say it's a bunch of streaming baseball data, and I want to know the impact of attendance on a pitcher's ERA over a period of time. I take a snapshot of that. If I'm the data scientist, I run that algorithm and query on a specific day. I get a result. I start to munge on that data result. I look, oh, you know what? My algo is off a little bit. Let me change the algo. But now that data has changed. So I don't know if it was the algo or if it's the data that fixes the problem or was the problem. So what they've done in the past is they take a snapshot of the data, they copy a full data set to a share, run it against that data, and that's how they do their versioning versus just some intelligent way of doing versioning.
So versioning's probably a misnomer for this particular use case. Versioning more comes into place down here, which I'll get to in a second. But basically, it's not even as clean as that. Really, what we see a lot of these data science teams doing. It's that they'll have a data set somewhere that they've kind of picked out and said, like if we use the pitcher ERA example, they'll have, based on attendance, they'll have kind of the attendance data set, right? And they've
Mm-hmm.
decided, we're going to train a model that predicts pitcher ERA based on this attendance data set or something like that. And basically their goal is to train the most accurate model, right? So they've got one data set, maybe, attendance over the last 10 seasons compared to pitcher ERA or something like that. That's their one data set. And they'll say, we need a model that fits this accurately to predict pitcher ERA based on attendance. And so they'll basically what they're going to do is use it, tweak different hyperparameters, different aspects of the model architecture to train something like, 10, 20, 30 different models to see which one is most accurate. But each time they do that, there's often kind of a change required in the data set to support the different model architecture. So it's not always 30 different times, but if they're training 30 different models, maybe they're copying their data set 10 different times, right? And each time they copy it, it's often hours if it's a massive data set. And so we said, basically, we can apply our volume cloning technology to this. And, if you want to perform another experiment to try and produce a more accurate model, you don't have to wait hours to create a copy of your data set. You can, in 2 seconds, have a copy of your data set and get on with your experiment. And if you manipulate that data set, you're not affecting your gold source at all. So you could, very quickly clone your data set, train a model, and maybe it doesn't look good, throw it out, clone it again, train another model, and you've still got your gold source there. So it does away with that problem of kind of having to wait forever to make copies and then having copies all over the place. Where versioning comes into play is when, and this is more so applicable to, at least we've found in talking to our customers, to industries like financial services and healthcare, right? Where if they're deploying a model to production, their compliance department's not letting them put that model in production unless they can say, they can fully explain the model. And part of that is they need to be able to say, this is the exact data set we used to train this model, right? For SOX compliance, they need, in financial services at least, they need full traceability there. And so what they're kind of doing to support that is that kind of comes into play after the experimentation process, where they've said, okay, this is my most accurate model. This is the one I want to deploy into my production application that's, let's say, approving and denying customers for credit cards. Before they're going to be able to deploy that, they need to implement some sort of traceability that's like, all right, here's our deployed model. Here's the exact data set we used to train it. We've got full built-in kind of immutable traceability there. And we heard that challenge and said, hey, volume snapshots, they're a perfect fit for that, right? They have a long and proven history of being used in Fortune 500 companies, public sector, DoD, right, to near instantaneously version data sets. They're a perfect fit for this. And so, a data scientist can take, when they're ready to deploy a model to production, they can take a snapshot of their data set and just kind of save that snapshot ID in a tracking tool, in their model repository or model tracking tool as an attribute of the model. And it says, here's the snapshot of the data set that's tied to this model. I can go look at that snapshot, and that's the exact data set I use to train this model. Does that help?
You're on mute, Keith.
Yeah.
So there's the two different use cases. There's the cloning, which is, let me just get a copy of the data so I can have multiple people working multiple models against. And then there's the versioning, which is more applicable to the example that I gave, which is, I want to use the same data set and a underlying in a underlying, let's just call it streaming data and data that constantly changes, but I want a snapshot of that data, and I want to be able to run different models across that data. So it gives me, in theory, the ultimate flexibility. If I have a team that's doing a bunch of different things against a set of data, underlying streaming data, then that team can either work multiple models against that data, they can work different versions of the data, or they can do a combination of different versions of models and different versions of the data, but they can intelligently kind of organize that workflow.
Exactly. Yeah. And the traceability part is kind of key too. It really helps them efficiently implement that data set to model traceability for the production models. That's something that has really resonated with a lot of our customers.
So are people building any workflows with like Git to do that, or is this a big Git community? Because I think I've run into this problem in HPC in general, in which HPC seems like the perfect environment for containers, and people, but the community isn't into that. Not there is growing, but they're not. Is not part of that culture. Is Git part of the culture for data scientists in this workflow?
It is, yeah. So Git is part of the culture, but then it's not always Git. Yeah, there's kind of different levels of maturity among data science teams. There's the more advanced, you know, kind of more super technical data scientists who come from, places like Google and more of the web scale type companies. And I mean, they're building all kinds of custom workflows, right? And so they'll be more accustomed to using Git. And then there's the more kind of traditional enterprise data science teams, and they're not necessarily accustomed to using something like Git. They're accustomed to, they've got some experiment tracking tool like MLflow that they're logging all of their experiments to, and say, that also has a model repository that they're saving all of their models in. But those experiment tracking tools don't really handle the data sets at all. They're just
Right.
kind of for, the
So
models. Yeah.
So this allows for supporting both environments. So if
It-
you're super into Git, you can create, a super custom workflow. But literally, if you're just used to, just working with NFS shares and and a spreadsheet, frankly, and my workflow is a spreadsheet. At the minimum, I can save the 17 hours and do 2 seconds, and now I've just improved my existing workflow without changing the workflow itself.
Exactly. Yeah. And for the traceability piece, I mean, the idea is you could integrate it with whatever tool you're using, right? So, if you want to save your data set snapshot for traceability, you can save that snapshot ID in Git, in your Git repo, tied to your model, and you've got traceability there. Or you can save it in your experiment tracking tool, or like you said, you could even save it in an Excel spreadsheet. It
Yeah, and
kind
that
of,
integrity is just as
yeah,
strong as a hard copy, because it's the ID. And if I go back to my on tap interface, and that snap was deleted, it's just like it was just like deleting anything else. The traceability is still there. Is the data may not exist, but the traceability was still there, and I can go back and look and say who deleted the snap, et cetera, et cetera. So it's just as robust as the previous,
Correct.
actually even
And
more robust than the previous solution, because I have more headroom, more capacity to hold more samples, more versions of or more snaps of the data, more data sets, etc. So it's as extensible as my environment can get.
exactly. Yep.
exactly, Keith. And most of the time, usually, if you're training a model today, the accuracy is like 0.0 difference percentages on the third level down. And then if you have 100 images, you train the model a year ago on 100 images, delete one image and that accuracy will change. And usually data scientists will fall into this trap of, whether the data was the same or I am doing the parameters wrong, right?
Right.
So that's where having the same data at least tells you the data is right. Then let's look at the parameters that we changed a year ago or a year after.
So it goes from being asking impossible questions. I've talked about this in another realm, but it's true on this case too, which is the data scientists are asking themselves impossible questions that's impossible or near impossible to answer. This gives them the ability to ask these data integrity questions that they couldn't ask
Correct.
before.
Exactly. Yeah, and it gives them an answer when the compliance guy comes asking those questions, right?
Yeah, I
when
can
they're
see how
trying to
this is
put it in
super beneficial in
production.
a regulated environment like a financial services or even
Yeah.
drug discovery, et cetera. Like, how do I know that you're working off the same clinical data when the clinical data was updated two months ago? What was the updates? Now I got to go back and reconcile what was the updates from between when I ran the models originally versus when I'm running the models now, and if there's a material difference. And something like drug discovery or financial services, that's a material question.
Exactly. Yeah, we've talked to several customers who were basically like, they wouldn't let us go to production, right? We spent all this time working on this, and then it was just kind of wasted because compliance wouldn't let us go to production, and they were looking at this as a potential solution to that. So do we want to jump over to the demo now?
Yeah, so basically what we did next level, Keith, is we have this technology, but we don't want the data scientists to learn about ONTAP. They don't need to learn about ONTAP. How can we expose all these features that we're talking about into a single point where they can use these features? And that's why Mike has been working to integrate it into the tools. Maybe Mark, you can show slide number 6 and you can explain the layers where the data scientists exist, right?
Yeah, so I was saying on Thursday, kind of, during the storage field day, we had these solutions to these problems, right? The cloning, the snapshots, but the data scientists, the feedback we got from the data scientists and the customers we were talking to is, this is cool. We really want to use this, but it's not approachable, right? We have to learn your storage tool.
I've seen this problem in real life.
Yeah.
When I need to we deployed connection to internet to and put a transfer node in the place where people can transfer 100 gig of data overnight. And the data scientists were just like, you know what, the data transfer tools, I'm not familiar with it, not approachable. I'm just going to go to the FTP and transfer the data over the internet because I know the tools.
Exactly. Yeah, same exact situation we were running into. So it was resonating, but it wasn't really translating to, customers actually taking advantage of what we could offer. And so, we had a lot of customers who kind of had purchased a Ferrari, right? But it was parked in the garage, right? They weren't using any of these capabilities, or they were driving 25 miles an hour, right, around the neighborhood. So like Josep said, that was kind of the goal of this data science toolkit, was to wrap these capabilities in an interface that's going to be super simple and easy for data scientists to use, and also approachable, like something familiar, something that looks like the other tools that they're used to working with. So it's a toolkit. It's a Python program that can function as either a CLI utility, for those more power user data scientists who are used to working from the terminal, and so it's just one CLI command to provision a volume, clone a volume, snapshot a volume, right? Or for the kind of less power user type data scientists, they're most often working in Jupyter notebooks, right? Just coding Python, the Python training jobs. And so for you know, and their NFS volume is mounted just right there in their Jupyter lab environment. And so for them, it can function as an importable library of Python functions. So they, you know, like to clone a volume, they just import the clone volume function into their Jupyter notebook, right? And then to clone a volume, they just call the clone volume function. So it's
So
just clone.
it becomes just as simple as saying you want this process to take 17 hours or 2 seconds.
Yeah.
If you do import this library, and you're good to go. So because data scientists don't care about how much storage is used on the back end, that doesn't impact them. They do
Right.
care if they can save 17 hours.
Exactly. Yeah. Or if they can convince the compliance guy to let them go live, right? So yeah. So now, you know, it's really been resonating in a way that our stuff wasn't before, because now we can show them, you know, here it is, here's how you do it, and it looks familiar. It's like, oh, you know, that makes sense. I work in Jupyter notebooks. I just, you know, import a function and call it. I do that all the time, right? It looks like everything else I do. So it
So is
becomes,
the ideal is to go through each one of these environments that are super popular, because this is the when I see stuff like this is the pushback and challenge that I give storage vendors specifically, is changing the underlying habits of the DBAs, the data scientists, etc. Sure, cloning is great, but I can't get an Oracle DBA not to do a zero level backup. That's just that's how their minds work, and they won't trust the storage array to do it
right.
unless I made a level zero backup unless I made a clone look like a level zero backup, then they're fine because they're using the same tools that they're already accustomed to using. So the idea is to go to as many of these tools that are common to the data scientists and make it as natural as possible.
Yeah, that's the goal. So that's what we're trying to do here, to make it more approachable and really kind of help them consume these capabilities. This toolkit, we released it as open source, right? We're giving it away for free. So it's really kind of, the idea is, you know, not only for new customers who are looking at us, you know, for their AI workloads, but even for our existing customers who we already have, you know, who've already bought our storage and are already using it to support their AI workloads. You know, now they can kind of take advantage of more of these features.
So I like this. So what you're basically saying is this is not a new product in a sense. This is saying, look, all the NetApp goodness is perfect for AI and data science and all of that. You're already using it today. We're just providing that extra value add to do the orchestration for you. These bits and pieces that take some development work, we'll do the development. Just use the underlying NetApp storage to do it. Because in theory, in practice, if I'm doing this on-prem, if I'm consuming NetApp cloud volumes and NetApp services in Azure, the same process is available to me, and anywhere I can get ONTAP, that ONTAP interface.
Exactly. Yeah. So that, yeah, this toolkit it's built on top of ONTAP REST APIs, right? So it works with any flavor of ONTAP, be that one of our on-prem appliances, our software-defined ONTAP Select, or the Cloud Volumes ONTAP. So which could be in any of the 3 clouds, like you mentioned. Yep.
Okay, this was clever.
Yeah. So, and Joseb mentioned the use cases just real quick before we jump over to the demo. Yeah, the idea was, we've kind of already touched on this, but the idea was we wanted this to be something that a data scientist could integrate into any existing tool that they're using, right? We wanted it to be simple enough to where they could just fit it into their workflow with their existing tools as kind of a value add. So it could be standalone for smaller teams who don't have, you know, a lot of tooling, or you know, they could fit it into their existing MLOps tool set, be it a proprietary or even a homegrown MLOps tool set. All right. So let me jump over to the demo and hopefully this is going to work. Unfortunately, I'm in the process of rebuilding my lab environment. And so I am going to have to use the YouTube version of my demo and kind of skip through it. My simulators and everything in my lab are down.
We don't have to go through the, if there's a YouTube to it, just send me the link and I'll take a look at it. This other part of the conversation is way more valuable than actually seeing, the demo. I can always reference that
Okay.
on YouTube.
Yeah, that works for me. I can send you, we've got 2 demos out there. One is a cloning demo and one is a snapshot demo. So I can send you both of them. And then there's actually I'll send you this as well. There's an interesting blog post that we put out that shows, kind of uses MLflow as an example and shows how what I was talking about, the snapshot ID can be integrated into the experiment tracking tool to implement the traceability. So I'll send that over to you as well.
Yeah, I like this. This is not disruptive to the existing workflow, which is one of the things just whenever I look at these storage enabling technologies from an IT infrastructure perspective, it makes perfect sense. But what I've always where I've run into trouble with adoption is that there's something that's non-approachable to, unless I'm working with, and I don't, unless I'm working with a Google or an advanced team that can build around APIs. Data scientists and these groups and similar groups just don't, that's not what they do. So, they learn the tools that they need and they use them.
Yeah, that's exactly what we ran into when we first were pitching snapshots and clones for AI, is that the adoption just wasn't there for that exact reason. So that's the problem we're trying to solve. And we just released this a little over a month ago, so it's new, but so far it seems to be resonating.
Yeah, I think the story makes sense. I love when you guys get an update on just how it's being received. I love to hear about how it's being received, because that's kind of the money piece. If you can crack that nut.
That's what we're trying, Keith.
No, I think this is probably one of the more forward-thinking examples that I've seen of using existing storage because you don't need anything new other than the shim in between the data scientists that make that makes the thing appealing to begin with.
Right. Yeah. All right, Keith, any questions? I hope this was useful time for you.
Nope, this was useful time. I really, it's been a while since I've talked to NetApp in general, so I really appreciate you guys taking out the time and walking me through this. This is, I love it. It was at my level, and it was probably a little bit more consumable than the field day thing, which is kind of geared toward a broader audience.
Yeah.
Yeah. No, thank you for your time.